Hi, welcome. This is a lesson on how to simplify radicals. A square root is asks for a number that we can multiply by itself to get whatever is under the square root. For example, the square root of 1 is 1 because 1 times 1 is 1. And the square root of 4 is 2 because, for the same reason, 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. And the square root of 16 is 4 because 4 times 4 is 16. And so on and so forth. With square root of 25 is 5 and square root of 100 is 10. So the radical, this symbol here, is used to denote square roots and nth roots. The square root of 49 is equal to 7 because the 7 times 7 is 49. And the cube root asks what number multiplied by itself 3 times is 8, and this is equal to 2 because 2 times 2 times 2, 3 times, is 8. And therefore, the cube root of 27, what number times itself 3 times is 27, and that number would be 3 because 3 times 3 times 3 is 27, so therefore the cube root of 27 is 3. The index is the small number by the root. So the index of the cube root of 3 is 3. And as it says here, if the root doesn't have a number, the index is 2. It's a square root. So the index of the cube root of xy, the square root of xy is 2. So the number right here is understood to be 2. All right. Steps for simplifying radicals. We make a factor tree from the number under the square root. Break it down as much as you can. Find groups the size of your index of the same number. Pull out from one number from each group and multiply whatever is left together. Let's look at the first as an example. The square root of 12. So I'm going to do my factor tree a little bit different. I'm going to start with 2. And 2 times 6 is 12. And I'm going to go with 2 again. 2 times 3 is 6. And this is the prime factorization of 12. And so we can rewrite the square root of 12 as 2 times 2 times 3. And since we have the index is 2, that number that's not there that we understand to be 2, we're going to take a group of 2 2s, and that's going to come out from under, and we're left with 2 square root of 3. In this case, there was no need to multiply anything together because there was just the number 3 underneath the radical. And so 2 square root of 3 is the same as the square root of 12. All right, with 72, I'm going to go off here to the side here, and I take 2 goes into 72 36 times, and 2 goes into 36 18 times, 2 goes into 18 9 times, and 3 goes into itself 3 times. And so I can rewrite the square root of 72 as the square root of 2 times 2 times 2 times 3 times 3. And once again, this is square root, so we're looking for groups of 2. So I've got one group of 2s and one group of 3s. And each of those comes out from under the radical. 2 times 3 times, again, there's only one number under the radical, so it stays under as 2. And this 2 times 3 gets multiplied together. We get 6 square root 6 times the square root of 2. And if you put this 6, if you put 6 square root of 2 and the square root of 72 both in your calculator, you'll get the same decimal. This is one way to sort of check to see if what you have is equal to what you had started with. So 48x to the fifth. So I'm going to take 48. 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. 3 is a prime number, so we're done. And I can rewrite this as the square root of 2 times 2 times 2 times 2 times 3. And then I've got x to the fifth this time, so I also have x times x times x times x times x 5 times. And I'm looking for groups of 2, or pairs of numbers, because, again, it's a square root. So I've got one group of 2's, another group of 2's, a group of x's, and another group of x's. And each of those comes out 2 times 2 times x times x. And under the radical, I'm left with 3 and 1x. So there's 3 and an x. And then I multiply everything together. 2 times 2 is 4. X times x is x squared. And then I have the square root of 3x. The square root of 3x under the radical. And that is the end. All right, let's look here. This time we have a cube root. So we'll see what that looks like here in just a second. Let's do the factors 250. 2 goes into 250 125 times. And now 125 is not, it's not even, so we can't divide it by 2. So I look at 3, and it's not divisible by 3. The next prime number is 5. And 5 goes into 125 25 times. And 5 goes into 25 5 times. And so then I can rewrite this cube root. The cube root of 2 times 5 times 5 times 5 times x 2 times 4y multiplied by itself 4 times. And this time we're going to circle groups of 3. And so I have 3 5s and I have 3 y's. And you can just circle them. So the group of 5 5s is going to come out as a single 5. And the group of y's is going to come out as a single y. And then I have the cube root of 2 x squared y, which is what's left. X times x is x squared, and I just have one single y, and each of those stays under the radical. Make sure that you show your index there. You started with cube root, you need to have a cube root in your answer. Unless, of course, it's like the cube root of 8, like we had up above here. The cube root of 8 is 2. It just was a whole number, 2. But if you're simplifying the radical, you need to have that cube root in your answer. All right, let's see. It looks as though I skipped D. Excuse me, let's go back and do D. So D, 108. 2 goes into 108 54 times. And 2 goes into 54 27 times. Then we go to 3 because 27 is not even, so we go to 3. 3 goes into 27 9 times. And 3 goes into 9 3 times. So I can rewrite the cube root of 108 as the cube root of 2 times 2 times 3 times 3 times 3. And I have 3 3's. And so that comes out as a single 3 times the cube root of 2 times 2. And the cube root of 2 times 2 is the cube root of 4. So just because I have, in the last couple examples, we had square roots, and so we had a pair of 2's, but here we need it to be groups of 3. Since there's only 2 2's, that just stays under the radical. And so this is our final answer. All righty. Let's go to the next page. We're going to jump into complex numbers. So complex numbers come from negatives under a square root. If it's defined as being the square root of -1 is the imaginary unit I. And I squared is defined as being -1. When you are making a factor tree for a negative number, your first step is to break it down to -1 times that number. And that -1 is going to come out from under the radical as the imaginary unit I. So I look at -32, and I can write that as -1 times 32. But 32, we're going to break down 32. 2 goes into 32 16 times, 2 into 16 8 times, 2 into 8 4, 2 into 4 2. And so I have 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's. And it's a square root, so we're circling pairs. There's one pair of 2's, another pair of 2's, and each of those is going to come out as the number 2. So 2, 2, there's one for one pair and one for the other pair. And then I've got -1. The square root of -1 is I. And then times what's left under the square root, which is just the 2, so that 2 stays there. We multiply everything together, we get 4I square root of 2. That's how I do it. Look at G. We've got, let's go off to the side here, 81. 2 will not go into 81. So we start with 3. 3 goes into 81 27 times. And 3 goes into 27 9 times. 3 goes into 9 3 times. And so this is the square root of -1 times 3 times 3 times 3 times 3. And each of the 3's is going to come out as this pair of 3's, and this pair of 3's is going to come out as a 3. So that's 3 times 3 times I. And I is the square root of -1 when you take it out from under the radical. So 3 times 3 is 9, and so this is 9I. And then we've got, let's see, the square root of -18 x cubed. 18 is 2 times 9, and 9 is 3 times 3. And so the prime factors are 2 times 3 times 3. So we have the square root of -1 times 2 times 3 times 3 times x cubed. And that gives us, we've got one pair of 3's and one pair of x's. And so, and then we have the square root of -1, which is I. So I get 3xi times the square root of 2 and x. 2x. All right, let's see where we're at. That was H. Let's look at I. Okay, I'm going to invite you to try I on your own. I'm going to ask you to pause the video and then come back and see how you compared to what I've done. Pause your video now, and I'll be right back with you. Okay, welcome back. Here we go. We've got 72. 2 goes into 72 36 times. 2 goes into 36 18 times. 2 goes into 18 9 times. Then we switch to 3s. 3 goes into 9 3 times. So the prime factors of the cube root of... now, I need to pause here for just a second and address the idea that it's different when you have a negative under an odd number radical, an odd index radical. Because if I ask myself what's the cube root of negative 8, it's what number multiplied by itself 3 times is negative 8. And this is not an imaginary number. This is negative 2, because negative 2 times negative 2 times negative 2 is equal to negative 8. And so that's not a imaginary number. That's a real number. And so we don't need to use the imaginary unit I because the index is 3. So I'm going to put negative. We'll just know that the answer is going to be negative. I'll put negative 1 still. Negative 1 times 2 times 2 times 2 times 3 times 3. And that's going to give me, it's a cube root, so I've got one group of a group of 3 2s, and that's the only group of 3 like numbers that I have. So that 2 is going to come out. It's going to be negative 2, and then the other 2 3s are going to stay under the radical. This 3 and this 3 are going to come out from under the radical, and that's going to come out as, those 3's are going to stay under the radical, and they're going to stay under the radical as 3 times 3, or 9, the cube root of 9. And that is the end. Thank you very much. Practice, practice, practice.